Alright, hello, this is Wade, and today's agenda, I disprove dark matter theory with a simplified model of attraction of objects in a galaxy. This is, each of these A, B, C through G are indicative of rings. I simplified it a little bit in a galaxy, and each of them has a same mass. Alright, so I assume that the galaxy is symmetrical. I put 10 times the mass of each of these smaller objects inside the central object. Okay? And we'll consider like center rings can be considered part of the bulge, whereas outer rings are part of the disk. When we do the math of what the net attraction is felt in a spiral galaxy, which I have done across these other pages back here by hand, when we do this math and then we carry forward all our results, we add up the sums and we carry forward all our results. Ta-da! The acceleration at the center, at point A, the acceleration I came up with negative 1.92. At point B, we get negative 1.26. At point C, it's negative 8.2, or 0.82 rather, and then something funny happens. The curve levels off for a while at negative 0.7, negative 0.7, negative 0.86, and it actually starts to increase again when we get out here. Why does that happen? Which is actually very close to what you see in the observed curve. What happens is, in a real spiral galaxy, this goes on for a long time until this number falls off and you can't see it. But I produced, without the assumption of any dark matter or increasing mass in halos out here above what was necessary, I stepped to the same amount of mass, and actually the density of this thing is going down slightly because as we get farther out here, the area of the circle is greater. So the density of this galaxy is going down just as you go out from the center, just as real spirals do. Alright, slightly. I was able to produce a result very similar to the observed curve where it stays constant for some time, or approximately constant, 0.82, 0.7, 0.7, 0.86. Alright. By hand, without the assumption of increasing density by halos, okay? And I did this using nothing but Newton's law. I didn't insert any dark matter. I didn't insert any funky physics. There is no... This is what Newton's law says. And I summed up the forces here. You can see that here. I had to scratch that out because that was a little bit of a mistake, and redo that part. But the rest of it was done correctly. There is no dark matter. There is only dark-minded physicists who are making the same mistake repeatedly and assuming that they're doing something right, and they're completely wrong. I have tried to explain this to people, and they don't listen, but I'm going to put it on YouTube and let anyone who cares take a look at it. It works. There is no need for dark matter. I don't know what else to say. There's no need to say anything else. Because if I drew the matter curve for what a dark matter halo does, you would actually have to put more and more points of mass out here and get this mass up much higher, because you need the mass to stay really high out here, according to the dark matter theory. But all I did was Newton's law, and it produces about the right result with just a square approximation of a galaxy. You'd get slightly more accurate results if I drew like a diagonal line, but in a certain sense, if I curled this up into a spiral with 4 arms, it would give the exact right results. So, you know, whatever. This is Wade signing off with the correct solution to the non-dark matter. Thank you very much.